My name is Jason Lohrey. I am the Chief Technology Officer for a company called Arcitecta. We are based in Northcote in Melbourne, and we build data management and big data software, or software for big data. We build that and make that software for entities in Australia, and we also export that to companies around the globe. I wanted to talk today about the art of software making and the intersection of software and art and science. It is a big theme for us that we unlock creativity in all of its forms and leverage the power of art and science. And hopefully I'll actually get people to think a little bit outside of the box that they normally might, how you might normally think about software, because in my view we need to as many creative inputs as possible to create the best possible software. I'm going to use some props. I will use some slides because I can't do it without that. Okay. So here I think is an interesting question. Is software art? Is it an art form? And I know that we all study software, computer science, software engineering, etc. And it's often deemed to be a science and an engineering discipline. But I would contend that it's both a creative art and a science. And I'll elaborate on that as we go further. So I have an objective for today, and that is really for you to understand what the power is that you have in your hands with software. Basically, I've come to realize that software presents the opportunity to make anything that you can conceive of. You can express any concept and idea, and in that is a very powerful tool. But we have to realize or see that potential. I think we need more makers, people who make things. We really need more people that are interested in first principles. That is, to be able to create things from nothing, from the very most simple elements, and invent new things not yet invented. I'm sure many of you will be wondering about the kinds of environments that you work in going forwards, whether they'll be large companies, large, well-established companies. It's interesting to note that much of the underpinnings for computer science were determined in the 1940s, 50s and 60s. There aren't that many revolutionary discoveries in computing, which edging our way towards quantum computing. But actually in the nature of software itself, much of that is underpinned by maths. A lot of it actually out of cryptography in the Second World War, etc. And today we have a lot of people that make software through assembly. I think we need more people that can generate new first principles and invent things not yet invented. And I'd actually really like to for people to think about the impact that they make with the software that they construct. Just a little bit about me. I'm actually one of you. I'm considerably older, of course, and sort of wind the clock forward. Even though I run a company and I'm the Chief Technology Officer in that company and the CEO, I actually, the thing I love doing the most is writing software. I'm undernourished if I don't do that. And in general, I'm a maker of things. So whether it's woodworking, whether it's composition music, whether it is some form of art, whether it's metalwork, whether it's making software, they're all forms of expression. And I'm going to sort of hopefully lead you into a world that involves software as an art form. Just so you know, my background is I have a mere Bachelor of Science from the University of Tasmania. My majors were physics and computer science. In the inputs to that degree were really the themes of computer science, data structures and algorithms, etc. Software engineering, so the construction of microprocessors, that was in the engineering faculty. Also quantum physics. Underpinning a lot of that was maths and as well as some fine arts. So I have a fairly broad background, and I think from a long time, from the very beginning, I've had a input from science and art. My career unfolded as following. I worked at Comalco Aluminium in Tasmania, working on process control systems and really trying to work with the team to invent new ways of smelting aluminium and reducing the cost of that process. I then stepped sideways out of there and went and worked in more creative industries in Kodak. I worked on a project called Cineon, which is a non-linear editing and compositing system, and really at the forefront of the revolution in digital filmmaking. That team actually went on to win an Academy Award for technology in the early 2000s. Also then we worked with Discrete Logic, a company similarly making non-linear editing and compositing applications. But it's not all like that. I did regular consulting for a company for Telstra, you'll all know, and in the early 2000s started the company that I now work at, Arcitecta. On the software front, I've written over 1 million lines of C and C++. That's actually quite a lot of software, and over 700,000 lines of Java. You have to put that in perspective. The US Department of Defense has accredited the standard for the development of well-tested software is 400 lines of software per year. And that's completely contrary to the idea of actually being agile and fast moving. So it's a challenge to combine both agility and robustness in software. I've also dealt with and used a lot of other languages, and in my view, the language really doesn't matter. They're all fairly similar. They're all there for a particular purpose to convey certain concepts, and you usually pick the tool that is best for the job at hand. And it could be in any language. It doesn't really matter. So it is quite good if people are multilingual and aware there are concepts in each one of these languages that are translatable to the others. I thought I would ask the question, what makes great software? This is what I think it involves. I think great software is something that has an impact. Now, people might think that great software is software that you make a lot of money from. Well, that's one vector. But if you think about it, really great software that has a long life is something that's going to have an impact on people, society. There's no doubt that Facebook has had an impact on society. I'm not sure whether it's good or bad, but nonetheless, it's fairly significant. And Google and Microsoft and all those large companies. Good software is resilient. So from a technical point of view, it's something that is robust to failure, that will, it's well made. From a computing formal point of view, it is fit for purpose and able to execute or produce the desired outcome in the smallest number of steps possible. That is, it uses the least computing resources, both disk, CPU, etc. And if you've ever had any exposure to writing assembly language, you'll appreciate those aspects. So those are sort of technical things off to the side. Great software comes as a result of a space to think, the space to think and innovate and think outside the square. It doesn't just come along. Often good software or interesting ideas in general are the result of people sitting and just laying on their back and staring into space. And we often need an intersection of ideas, that is interconnection with other people. We need diversity, etc. But I have come to realize that software has parallels in multiple art forms, in that it requires an audience. You cannot produce software in isolation. It's very unsatisfying just to produce software for yourself, except to learn how things work. And I actually encourage people to play and iterate many, many times over. But the most enjoyable software is something that other people use. So there are parallels here with a performance. I've actually I've been involved in live performances, and there is nothing more satisfying than at the end of a performance having the audience clapping. The same thing happens with the development of really good software. If you do something that people don't expect, that it makes their life easier, and effective, people really appreciate that. Space to think is important, as I said, and the software platform that we create actually had its roots in this place, which is in Arthur Boyd's place in Bundanon in New South Wales. I was very lucky. My wife is a choreographer, and she has had a residency at Arthur Boyd's place, along with writers and sculptors. And I asked if I could go along, and they said, "Oh, that's pretty unusual. We never had technologists come and ask to come to Bundanon, but they let me in." And I realised at that point to actually take a computer with a clean slate and sit in a studio with other artists who are all creating and ideating, and we'd meet at night and discuss. It was an excellent process to start with a clean slate and think, what could I make? And that point where you sit there with a blank sheet of paper is the most enjoyable place to be at, and think, what can I do to change the world? What can I do to make an impact? If I could make anything, what would I make? And so the software that we've built our business on over the last nearly 20 years had its seat in in an artist studio. What makes a great software maker? These are my personal opinions, and there may be many sorts of factors that people think of in terms of making a good software, of someone being a good software maker. In general, I think the best software makers are those that are the most highly skilled at their craft. No different to a painter who is able to create abstract imagery or concrete imagery easily and readily, to take an idea from their mind and put it onto a canvas. A great software maker is no different, able to conceive of abstract entities and concepts and take those and wrap them up in software. And I often think about software as being a virtual sculpture. So these are things I think are really important to a person being a good software maker. And I just, in random orders, you need empathy. Without empathy, you can't relate to your audience. So in most cases with software, you're creating something that people want to consume. So you have to understand the consumer, and you have to be in their, you have to be one of them, and really listen to what they want and what they need, and not only listen but to actually know in first person experience what's required. Because if you don't do that, you're never going to produce something that is the perfect fit. Of course, you need experience, because there's nothing like experience. The patterns become more obvious as you get further on. But equally well, people have excellent ideas that are well equipped to make things very early on. I'm talking about art and the importance of creativity, but you can't underestimate the power of being methodical and and being an engineer. Both of those things have to come into play, probably in equal measure, in order to be a good software maker. If you want to change the world or do something that others haven't, you have to be a big thinker. I used to sit there and think, could I build a sentient machine? I don't know that I want to build a sentient machine. I'm not sure actually that is a good outcome for humanity. But I used to sit there and think, what would it take to build systems with that were artificially intelligent? Now that's a long time ago. The world has rolled forward, but we're not there yet. There are many things yet to be made and discovered, and there's a lot that we don't understand about the universe. The point about software being that you can actually model any concept and possibility, including trying to figure out how the universe fits together, if you've got insight. And for that, you need creativity. You've got to think outside of the box. Very importantly, you need to be perseverant, because like writing a book, everybody likes reading a book at the end, but what goes into writing a book, the initial idea is a lot of creativity and a lot of grinding it out, a lot of tedious aspects. And this used to happen in motion picture and film. Everybody sees the special effects at the end. What you don't see in the back room is a factory of workers and people just cranking the process out. Try this, try this, try this. They enjoy it because they all enjoy the outcomes. You need to be an abstract thinker and an effective communicator, because if you can't communicate what your ideas are, you're not going to be able to relate to the people that you're producing software for. And I think people need to be multi-skilled, breadth quite wide and deep, to get the best software. Now, there are many pathways all along this curve. I'm talking about if, as an aspiration, when you really are true, and I don't know there's a gender non-specific form of saying this, but a true master craftsperson, not craftsman, but craftsperson, to get to that level, a master craftsperson, you need to be totally in control of the tooling, and it should be very easy for you. I've put Da Vinci on there. We think about Da Vinci as a person that was multimodal and underpins a lot of our world today. Very forward thinking. I've also put Antonio Gaudi up there on the left, and I'm going to talk to some of the things that Gaudi did. I've got a little thought provoker here, and I often ask people who work for us and who did I interact with, what is the most powerful software tool? And I normally would ask people to come back with an answer for this, because it's interesting to think what that might be. I know I've got questions and answers at the end. Actually, if anybody's got an idea, just yell out, what do you think the most powerful software tool is? Probably all muted. I'll help you. I think the most powerful tool for making software is this: a pencil and a blank piece of paper. If we cannot sit down and represent a concept on paper, it's very hard to represent that concept in software in any form. So it doesn't. This is my pad. It's very doggy here that goes around. I just doodle on things all the time. You'll find that that it's a way of capturing thoughts, but you need clarity, and you need to start from the top down and work down, and you need to be able to draw your ideas and to be able to communicate those with other people. So many times I see people diving into software and just careening ahead. You basically got to stop, go back, and just get a pencil and paper out and work it out what the problem is in the smallest possible steps, in a way that you can convey it to other people. You will probably make mistakes, and I made this mistake early on. One of my aunts is a fairly well-known author in Australia, and I accidentally deleted 80,000 words of her novel. I think that was in 1989 or something like that. Terrible experience. We had to go through the process of recovering that data forensically. It was on floppy disk. Wasn't so easy. It can still happen today. People lose data very easily. But that experience actually I refer to that experience today, nearly 30 years on, as an underpinning principle in terms of the way in which we write software. I have to think about that. Without that experience, we would not be thinking about our software in a way that ensures maximum resilience. So the experiences that you have in everyday world will impact your ability to design a software and to conceive of new software ideas and to empathize with the people around you. Actually, in the end, it was okay. We recovered most of the novel, but also she rewrote a lot of it from printed out copies that she had. In terms of thinking of art, I want to sort of draw attention to the Sagrada Familia in Barcelona. This is an incredibly well-known building in Spain. It was designed by Antoni Gaudí in the late 1800s. It's a building that is still being built today. But we're going to have a look through this building and look at the constituent parts of it. As it turns out, the current chief architect for this is a person from Melbourne, Australia, and the building is still being built to today. Still being constructed. It has incredible intricacy in its design and construction. It is a most beautiful building. This is a photo from the inside of the building looking up into this, essentially what is the ceiling. Those structures that are holding this building up, it was not possible for people to model that using traditional CAD/CAM software. It wasn't until the advent of aeronautical engineering software were they able to properly model the structures that Antoni had developed for this building. He developed those structures through a lot of experimentation, modeling and playing and experimentation, basically. As some more photos, the detail on this building is incredible. As part of the outside of the building, it's almost like a fractal. The more you look through it, the more you see. No wonder it's taken so long to create. The building is constructed or modelled. A lot of there were models created of it early on for play and experimentation. And you might be thinking, wow, why we're talking about this, we're talking about software. There are very similar parallels to the construction of good software. And what I'm trying to get across is the idea, as we go through this, that a diversity of input leads to potentially incredible outcomes. Aspects of the geometries in the building here, we see little fragments or models of the scalloped parts of these support structures. They're based in maths. So you're talking about a person that's building a building that has very tactile and has human relationships. It relates well to humans and is incredibly beautiful, but actually is built on geometries and principles and maths to create an incredible outcome. He experimented with dropping gravity and looking at the way when you had fairly liquid materials under gravity and looked at the shapes that they formed. And looking at that actually then informed the structures of the buildings. And you'll see on the right here some of the modelling that's since been done on those shapes. But those shapes weren't necessarily handcrafted. They were actually made by using gravity, basically. And here are some examples of bags that we use to inverted structures to see what happens with the effect of gravity. All of that went together to build this building, and actually the inputs to this actually have absolutely beautiful drawings. This is pen and paper kind of thing, so the same sorts of things. The ideas that are in here in terms of the conception of the construction of this building are no different to the ideation that happens with the construction of software. The forms are most beautiful, but they also have relationship to nature. And the one thing about software is that essentially you can represent anything that occurs in nature. You can also represent things that don't occur in nature. one of the axioms I've discovered through nearly 30 odd years of software engineering is that you have to be able to represent and create models of things that have their true simile in nature. Because if you're trying to create something that doesn't have a one-to-one correlation, often they're not very resilient. They don't last. They're not very reusable. The universe has had many billions of years to sort itself out in terms of geometry, spin, etc. How everything fits together is very clever. Antony also used or made reference to the natural environment and the structure of the structures of bees, etc., in the construction of the building. And looked at these things, the spirals. All of these are models that were created by him and lots of other interrelated people. So this is where you use diversity and sharing with others to inform the construction of the outcome. The same thing in software. And they're experimenting with models and shapes that are fed into the building. Here's another form of representation or design. That's an interesting pattern. It's a waveform on one side, but actually really what it is, those are the pathways of dancers in space, looking to see on a timeline where they may intersect with each other to create a composite piece of art and work. It's very geometric. There's some maths in here, if you like, and there are spatial relationships that work on our eye. And for that, actually, it's a very enjoyable experience. And we sit in here and the underlying composition, the dance work is very well conceived. We as the audience gain a great deal of satisfaction from that. No different when you listen to well-composed music. Those are based on well-defined principles, but then in the hands of the composer to put those together and almost in infinite possibilities to produce unique compositions that again are pleasing to the audience. More representations of the structure of the work, the dance work. It could equally well be a software design. The elements of software, and again, it's done on paper before it's actually translated into space and onto people. So I'd say that these best concepts are developed, the best place to develop those concepts are on paper. So I've got a little bit of software here. It in my view, software itself is something that has beauty and form. And the form really deals with alignment in space, the spacing. It should read well and read like English, or read in a language or a form that other people can understand. It has symmetry. It has elegance in various ways. But an important thing about software is that it is equal parts, in my view, engineering and art. The software itself is something that can create. I often refer to it as virtual sculpture. You're crafting concepts in your mind, in one's mind. Often, it's the world of a mathematician is in the space of. It's a hard space to convey to other people, and it's the same with software construction. But the beauty in the construction of the software actually can solve problems that have really very real world outcomes. In my view, beautiful software has elegance of form. That is, that it has good spatial form, very legible. It has very elegant models internally. Those models are developed. The ability to develop a model and understand the essence of a problem it will depend on your ability to understand the environment, to empathize, as I said, And two different people will have two different conceptual representations of the same problem. But there are often, I find, there are very few models, and probably only one often, that are the best representation of a concept. Software creates a space of concepts, of data structures or algorithms. Those are the elements, the palette, if you like, for a person really good at software. They're able to understand how things should fit together very quickly, understand what data structures we need to be able to invent new data structures and algorithms. And to do that, you've got to be really competent in the tooling. So my fine art background includes painting. And one of the things you do for painting is that you practice painting or copying what other painters do. And you paint, you draw the lines out. Eventually, you get to a point where you start developing your own narrative and you branch off. And that's how the master painters actually started out. They would work with other painters until they developed their own style. But they had to be really competent in the mixing of paints, the tooling itself. And it is no different with software. You must understand, it should be second nature what data structures you use. The ability to actually manifest a concept is a function of experience and tracing and retracing that space. Software can model both physical and abstract concepts. So you can model the real world, financial transactions. You can model we've actually just landed, NASA has landed the Mars rover on Mars. That all software driven and algorithms and telemetries, etc. But there are also many abstract concepts that we can model. And as I said, people haven't yet figured out how to make a sentient being, but that will come. And then I'm not sure what's next. Maybe we'll actually conceive of ways of unlocking parts of the universe. In my view, software is the most versatile medium for creativity and expression. So fundamentally, the process of software engineering is one of creativity. It's one of expression, and it's an opportunity to make anything. It also requires a lot of being, as I said, methodical. It doesn't hurt to be good at maths and algorithms and really have a deal of formalism. And basically what I'm asking or sort of putting out to people is realize the opportunity that sits in front of you with software and to use it to its fullest potential. Really to think big, imagine making the next generation of something. Don't look at Google and Facebook or IBM. Think beyond them. Think of what you can make that replaces those. Most of those large companies have a life cycle where they're based on innovation, and they get to a point where they stagnate, and then they're replaced by the next levels of invention that are often the result of of individuals and small companies, and then those small companies grow to bigger ones, and then it repeats. The next ones come along. Often those larger companies buy or consume the smaller ones, so it's like the ocean, the larger fish eating the smaller ones, but that doesn't necessarily mean they're going to make a step change. And it is not unusual to see an existing business that makes a lot of money completely displaced by someone else coming up with a completely different idea that changes the way in which people look at the product that they've got. So I'd really like you to embrace UNIHACK to the fullest extent, to think broadly, to embrace as many different inputs as you can, and really to see software as an art form, and really an opportunity for you to actually sculpt and create something that will be greatly appreciated by a fairly wide audience. I'm going to hand over to questions. Actually, well, I've got a question for you guys. I'm interested in whether people actually, how people relate to that notion, whether you think it's a bit wacky, or whether you think that it is something that resonates, or whether it's something you've thought about before in terms of the way in which you view software making and software engineering construction, or maybe you've never thought about it. Or maybe you think about it all the time. Yes, Wendy. There is much to be gained from the intersection with other disciplines. Architecture, so I've referred to Antonio Gaudi, but there are many forms of architecture that are worth exploring, and really they're stimulating. I don't know how many times I actually have sat in a dance performance. Unfortunately, I tend to wander off, but the stimulation of the motion, the movement, the music, it really is a great way to unlock unrelated thoughts. And sitting in a building, experiencing beautiful architecture and thinking about how your software can be equally well constructed and have an impact on other people, and it can be very rewarding. Although, actually, I said often, it's very hard to convey to a lot of people what software does, because it's so abstract, and it's a bit like the math. Those people are into pure maths. They exchange those concepts with each other, but there is an audience. And in the late 1990s, I thought it was very nerdy to be in computing, and all of a sudden, in the 2000s, it's become popular. The rise of data and the power of data, and the number of people studying data and applying that, all of a sudden it's become pretty popular, and yeah, the nerds have come out of the cupboard, I guess, so to speak. Terence says, I haven't thought about software as art. I usually chuck stuff together and see if it works. I have to say that it's worth experimenting and playing. The very first job that I had, I was very lucky. The boss that I had said, I'd like you to play and experiment in the materials. Now, the very first thing I did was driving. You may not remember these things, but we had a line printer, and I actually did graphics on those things as the little dot matrix printer came across, and I got myself used to developing software. And then I got a little bit further up and started playing with process control systems. And so playing is actually very important. If you don't have space to think and play, if you just turn up to work and someone says, please create this outcome, then you don't have enough space to create or ideate or to think innovatively and think outside the box. You must make space. And as I said, the best space, I realized that in going to that place of Bundanon, completely out of normal lifestyle for technology person. And I'd really like to see more of those places applied for technology. It gives you the space to think. Yes. Yep, that's true, Lachlan. Anything you do make in software is an expression of yourself. It has to be. It's a creative outcome or a creative process. Now, the Department of Defence might not view software as a creative enterprise. However, you do need lots of creative ideas. Well, actually, put it this way: creating an aircraft control system really shouldn't be that much of a creative exercise. However, in one regard, it must be well tested. It's got to be robust. I remember doing a course in software testing early on in my career, and someone pointed out that the Star Wars program that the US government had put together, they looked at the number of defects that might occur in that program. So that is a weaponized satellite system in space. The best level of tested software could get one defect per million lines of code. The problem is that program required 50 million lines of code. So that means there are 50 defects that could actually wipe out humanity. So sometimes actually it's very hard to create an outcome. Paul's asked what's the role of testers and QA in implementing a more creative approach, in implementing the more creative approach that's been discussed. Look, I'm not saying that where there is it's all creativity. I work with people in the arts, all sorts of characters that you interact with. You still need rigor and you need formalism. You need to be able to prove that what you're doing will work, and you need to be methodical and you need to be perseverant. So you still need quality assurers and testers. But equally well, you need the wacky people that just think in all sorts of, and the QA people can be thusly wacky also, because they might think of ways of testing things or making things work that are invariant of human error or foibles. And it's very hard testing things at scale. So we need people to be ingenious in that regard. So it doesn't remove the need for people like that. Everybody has a part to play. I just would like the people who make software to think of it as the actual producers of that in the first place, to think of it as an art form. Paul's asked, also, do you see the more engineering and systematic design approach to coding proposed by dev gurus like Uncle Bob Martin being detrimental or beneficial to the above? I suppose following on from what I just said is that you need both. The biggest threat to most large organisations are the smart cookie where the penny drops that's sitting in their garage. I think Hewlett-Packard was started on the basis of two guys in a garage, and you can't protect from that. But you do need to be systematic. But creativity is not something you learn. It's something that you can just read in a book. It's something that you can develop it, I think, by opening yourself up to external influences. And basically what we're trying to do is to innovate. I gave an interesting idea to some of our developers recently, an interesting problem, and it was a very simple problem. How do you solve or index or find a way of, at large scale, enabling people to search for star, cat, star, dog, star at scale? Now that problem looks very simple on the face of it, but it's actually much more complex than people realise. And there are lots of algorithms and approaches out there. There are all sorts of papers that you can read. And not very many people have solved that problem. We have to solve it, and the only way to solve it is to think laterally and innovatively, not necessarily systematically. So insight comes from insight and lateral. Being lateral. Insight comes from being lateral and thinking outside of the square, but the systems actually prove that they work. So I think both are plausible. Yes, thanks, Anthony. Presentation. You did a presentation at uni about how software should be art. I really want people to think about the creative side of things. You're asking, are there any examples of recent software or software companies that you think embody this notion really well? Well, we do, because that's the thing that actually drives us. And that's based on my view that we want to. But there are lots of people out there. If you look at Linus Torvalds, I don't know that he actually used art, but he's pick the innovative people in the world that actually have generated things that have an impact on computing and society, and then look at the inputs that enable them to be creative. To be honest, I don't know Linus at all, so I'm not quite sure whether he has art or taken art in certain forms that have actually influenced him, but something's triggered him to think creatively and outside of the box. This is my view. I think I can't necessarily think. Maybe you look around and see if you can find some other examples of people thinking this way. I think on average, people don't think this way. And I think that it means we're not realizing our full potential, basically. Audriana has said, I always thought that software is somewhere like maths in a way that helps to solve many problems, but after, it is a creative thing. So you pretty much took it further and explained how it can also be creative, be creativity in art. I think there's a lot of maths in software, and a lot of software, the underpinning theory is the result of mathematicians, as an outcome of mathematicians. And I think we need more maths. And one thing that I lament a little often is that people do maths at university and then their maths disappears. So it's one of those things, if you don't use it, you'll lose it. My maths wasn't that strong at university. I didn't pass enough at year 12 to get into university, so I had to plead to do maths there. I got in, and then I failed first year calculus, etc. But I was perseverant, and I went back. And so, but I do really appreciate, and we use a lot of maths in what we do. So I appreciate it, and I see that as an art form in its own right. It's a very specialised one. But I sort of really like the aspect of creativity and as an input to creating good software. Any other questions? Hopefully I've changed the way a few people think about software. And
hey Jason, may I ask a question?
You may indeed.
My name is Deco. I'm just wondering, how do you actually define a good software maker? Are they the people who can actually write really decent code and understand a lot of low-level system stuff, or the people who are actually concerned about how people is going to use the software they make and how people feel about their software?
I think both of those are valid. I think a really excellent software maker is someone who can go, oh, I understand what you need, or I can conceive of what you need, and can make it happen with the least possible effort. So they can understand the model. Sorry, I'm going to, pardon me. They can understand the model and produce an abstraction very easily and quickly. And you can see the abstraction in the problem space. You can take a problem space and you can see a way of dissecting that. And actually, that's why I've got such an interest in art and form and spatial, because a lot of this is about spatial thinking, about able to pivot a concept in your mind in that sort of multi-dimensional space in your head, and to be able to turn things around until you see a solution that fits into the space. So I think the people that are the best software makers, they're not going to be a person that says, oh, I'm worried about this language, or I'm worried about any language, or I'm not quite sure what data structures that I'll use, that they'll actually embrace that. If they don't know, they'll go and find out. And that the tooling, the use of the software is not an impediment to the outcome of an idea. Those are the best software makers. It's kind of an abstract answer, but there's no recipe that says what the best person is, except for the fact that you'll know when you meet them, because they're able to pretty quickly represent any concept in software. So it's basically easy. And that's why I equate that to the master craftsman, the master painter, or the master craftsman who's really good at creating a sculpture or painting or something like that. They're not at all affected by the tools. They're not worried about mixing the color. They know if they want to achieve a color, they know exactly what paints to mix to produce an outcome or a texture. It's the same with good software makers.
Yeah, cool. Thank you.
Wendy asked, is there a process you usually use when looking at solving a problem? I find that with fine arts, there's very little structure to how we approach projects, which is the opposite to computing. Interesting. If you are in the fine arts, interestingly, I've got a bit of a background in the fine arts, and I'm related to people that actually have worked in arts, performing arts, and I've been involved in performing arts projects. So I've got a bit of an insight into how that world works as well. That's why I showed an example a little while ago of a choreographer producing a thought-out process for space and time, because in choreography, there's no formal language for expressing structural choreography. A few people have tried, but there is no unified or universal language for codifying the construction of a dance work. However, different people will have their own processes and use, in that example that I showed, drawn with coloured lines in books, etc. There's a level of formalism that goes to that, but that doesn't take away from the creativity. So you can have the artist can both be creative and with a level of formalism, and I think the equal and opposite applies to, or the inverse applies to computing, is that you need formalism with a little bit of freedom to think, and thinking outside the square that you get that an artist has, and thinking laterally. And I don't think we have enough of that. We're too constrained often in computing and maths and engineering by the discipline itself, and it's really important that we do experiment with. And that's why I like at some universities now are doing breadth subjects. You really don't want to embrace breadth just to check them off and make sure you've got extra points and you've done your breadth subject. One should embrace the opportunity for breadth subjects to actually improve the way in which you think and see problems. Angus has asked, I used to think that fields such as software engineering or anything in STEM were purely logical areas where you would methodically problem solve, and gravitated towards it because I was bad. and add the traditionally creative subjects in school. But I believe this kind of thinking promotes that creativity is inherent in everything we do, That's true, Angus. I think a lot of software and engineering people are much more creative than they realise, and you need options to help unfurl that and reflect on and view that. And without creativity, we don't get as much innovation. You can crank the handle, you might get there, but that doesn't help you with the insight of the random jump to the right. So I think even for those more traditional fields, there is a lot of creativity, and then that's what I'm promoting. I'm not saying you actually have to go out and study art to write good software. I'm just based on my own experience, I'm making a correlation between the two. But I'm just pointing out that software is a creative. It's a software is a paint, as paint is to the canvas of a painter. It's no different to that. Paul asked, does this work in more traditional, less agile environments, say like large corporates where the requirements are often designed in strict design documents and approved by the business up front? I have worked in those environments, Paul, and I must say it's a little constraining sometimes. The people that are, but you can be creative in those environments and see how things should be put together. And still operate in those sort of more formal environments. So often there's a series of steps that need to happen. Each step along the way is an opportunity for creativity in total. I think in the end, though, they're less agile, and I very much value agility and agile. And that means you're producing things that people need, you're testing them on the environment as quickly as possible, you're failing fast, all of those things. And those are attributes that are not attributed to large corporates often, but they know they need to change. But to change, they've got to change decades of culture. And that's why I actually like working in smaller entities, but I also really enjoyed working in large corporates, because there's an opportunity to, even in your little ecosystem, to innovate and be creative. So I do think you can be creative in your language. I'm encouraging people that work here to improve their grammar and the style of their writing, because good writing is enjoyable to read. And so those formal business requirements documents, if they're enjoyable to read, you might actually get more out of the people that are reading them, and they might be more, instead of wading their way through it and actually it being a real chore, if they're well written with a bit of creative flair, they actually would probably get through it much more easily. B, do you have any advice on advice regarding cultivating creativity? I really admire people that come up with creative solutions. Find that sometimes I struggle with thinking outside the box myself. I would like to challenge myself thinking more laterally. Now, I think a lot of this it's environmental. So I actually encourage people to have a diversity in input. So I had an opportunity. Luckily enough, I failed. As I said, I failed maths in year 1, and that actually meant that my degree went from 3 years to 4 years when I did it. That gave me some space, and at that point, I thought, I'd like to do. I will take on doing some fine arts, and actually, I did have a fine arts background prior to going to university, but I gave myself a space. You've got to give yourself space, and in doing that, and doing something outside of the norms. And I often look for people that have got interests that are beyond just doing straight computing only or straight sciences, that have got that play music, that compose, that do have other forms of art or other forms of creativity. If you go and experience those, enroll in an art class, creative dance, basket weaving, go and do law. Do something that's outside of the space that you normally think, and it will actually stimulate your mind in ways that you've in unexpected ways. So basically, creativity comes from experiencing the inputs from others, and that could equally well be going and spending a year working in a not-for-profit with people on the ground in another country and experiencing something that you don't experience. So. Creativity and resilience is a function of pushing the boundaries in what you know and what you experience. And then hopefully that actually, but if you stay only in your lane, it's hard, and you're not thusly wired, it's hard to, it's hard for that just to arrive. So diversity of experience. Oh yeah, so, sorry, Paul said by the requirements documents, I should have said requirements and design docs, sorry. Yes, that's right, requirements and design. I've been a technical architect in some companies for a very long time, and I always used to take great joy in being creative in the design documents, or the design aspects, or technical architectures and solution designs. And the joy I was looking for was to be able to express and articulate the concept to the audience in the smallest number of words, and the smallest and most eloquent number of words that was easy to read, and that was well communicated. If there's one thing that I hate the most, and that is things like UML and those sort of formal recipe-based methods. If you follow this, you'll get to here, here, here. I think the best tool, I said pen and paper is one of the best software tools. I think the other tool we have that is the best tool is plain English, and being able to explain to somebody a concept in terms that anybody would understand. So the best software engineers or software makers are those people that can explain what they do to their neighbour, to the non-technical person in the business, to anybody else. Those people are really good software engineers. Any other questions? No worries. Thank you, Wendy. I hope people found that interesting and a little bit off centre, and a bit not what you're normally used to experiencing. And I hope you embrace the concept of creativity in software. Thank you. No worries, Paul. That's fine. Anytime.
Thank you so much. That was really interesting. And I'll pass on the recording to you afterwards.
No worries. Thank you very much.
Perfect. Thank you. And thanks everybody for attending.
Thank you very much. Bye.
Bye.
Uru. Thanks.
Thank you.
Good luck in
Thanks, Joseph.
UNIHACK.